Good morning, sir.
Yes, good morning. Is the previous class is still running?
सर केवल सीएससी के लिए क्लास है सर?
क्या सिर्फ सीएससी क्लास है?
मतलब इसी का क्लास आज नहीं होगा सर?
हाँ हुआ, क्यों नहीं होगा?
उन लोगों को ब्रांच में सर आप लिंक नहीं दिए तो वो मैसेज कर रहा है
लिंक नहीं
क्लास होगा
दिए?
या नहीं।
लिंक दिए हैं?
इसी ब्रांच में भी नहीं दिए हैं सर।
हाँ दिए हैं लिंक अभी, जैसे इस सीएससी और इसी दोनों में साथ में लिंक दिए हैं।
वो सर आप इस केवल सीएससी का वो ग्रुप है सर, आरएससी सीएससी है केवल वो ग्रुप सर।
अरे नहीं, आरईसी सीएससी 2024 और आरईसी ईसी 2024 दोनों में दिए हैं।
ओके सर।
सेम ही लिंक है दोनों के लिए, अलग लिंक नहीं है। साढ़े 11 बजे ही लिंक दिए हैं अभी, थोड़ी देर जैसे जैसे सीएससी में लिंक दिया मैंने अभी, जस्ट वही लिंक मैंने इसी में भी दिया है। Okay, let them join. Okay, let me share the whiteboard. So whiteboard is not working. Yes, here it is. Is the whiteboard visible?
सर ब्लर दिख रहा है।
Is it visible now?
Yes, sir.
Okay, so yesterday we have seen multiplexer. We have started multiplexer and we have seen the block diagram, the truth table, and the realization of 4:1 multiplexer. In the same way, today we will move towards 8:1 multiplexer, where the process will again be the same. Okay, so let us start that. So अभी अगर हम सिस्टम थोड़ा स्लो वर्क कर रहा है, इसलिए पेज जल्दी मूव नहीं हो रहा है. Okay, so today we will see eight is to 1 marks. Okay, so as here in this case also we have 8:1 multiplexer. So again, so here n, this is what, this is n, and this is the output. So what is the value of m? So m is what? M is what?
Select.
M is the select lines, number of select lines. So m is equal to, so what is it? No, sorry. So what, how we can find out the value of m? It can be written as n is equal to
n equal to 2 to the power m.
2 to the power m, where m is the number of select lines and as the n is the number of inputs. So as here n is 8, so we can write it as 2 to the power 3, and this is equal to 2 to the power m. So here by comparison we can conclude that m is equal to 3, that is the select lines. Okay, so if we have 3 select lines, then obviously we have select lines as S1, S0 and S2, S1 and S0. We will have 3 select lines, and based upon the combination of these select lines, we will have the output which may be equal to, so the output should be maybe so if we are taking the data as D0, D1, D2, D3 up to D8. Okay, so D2, here we will have D3, we will have D4, D5, D6, D7. Okay, so from D0 to D7. So based upon this combination of S0, S1 and S2, we will have the outputs. So the very first combination is 0, 0, 0. The second combination will be 0, 0, 1. The third combination will be 0, 1, 0. Fourth combination will be 0, 1, 1. Then we will have 1, 0, 0. Then 1, 0, 1. Then we will have 1, 1, 0 and 1, 1, 1. So based upon this combination, we will have the output. So ये जो 8:1 multiplexer का IC है, this IC is IC 74151. So this is the IC of 8:1 multiplexer. Okay. So this is 8:1 mux. So इसमें जो है वो total there are 40 pins, 14 pins are there. So among those 14 pins, there are these 8 data lines in inputs for the pins for these data line, 3 pins for select lines, 1 pin is the strobe input or the enable input. Okay, 1 pin is the enable input and this is active low. So Y bar is not coming here. Yes. So E bar, this is the enable input or strobe input, and इसका मतलब है कि when this is 1, so when this is 1, there is no need of these 3 inputs. The output will be 1 in this case. Okay, when this enable input is high, in that case, don't care about these 3 combinations, the output will be 1. But to enable all these inputs, means all these combination of S0, S1 and S2, the strobe input or the enable input should be 0. Okay, for activating these select lines, the enable inputs should be 0. So जब ये so it as this is an IC, so इस IC को हमें यूज करना है कि नहीं करना है सर्किट में, this will be dependent upon this enable input or the strobe input. So based upon the value of this strobe input, the pin will be activated. Okay, so we have this input. So beside this Y output, there is another output pin is there, which is Y bar. Okay, there is another input, another output which is Y bar, and for this output, if we are taking the output from this Y bar, then all the outputs of Y will be complemented, so it will be a 0. Here it will be a D0 bar, here will be a D1 bar, here will be a D2 bar, here will be a D3 bar, D4 bar, D5 bar, D6 bar, and D7 bar. Okay, so in that IC, there are 2 pins for output, Y and Y bar. So if Y is representing the uncomplemented part, then Y bar is represented for the complemented part. Okay, so based upon the values of S and S bar, we can write down the expression. So expression for what? Expression for the sequence, expression for the Y output. So Y output के लिए अगर हम expression लिखना चाहें, तो how it can be written as, okay, so let it be in black color. So Y output will be what? We will have the expression. So what should be the expression? So if we are writing in terms of D0, so we will have D0 for the combination of S2, S1 and S0 as 0, 0, 0. So we will have S2 bar, S1 bar, and S0 bar. Again, for the second term, that is D1, we will have D1, S2 bar, S1 bar, S0, plus for D2, we will have S2 bar, S1, S0 bar. Again, for D3, we will have S2 bar, S1, S0, plus D4, we will have S2, S1 bar, S0 bar, plus D5, S2, S1 bar, S0, plus D6, S2, S1 bar, sorry, not S1 bar, it should be undo हुआ, yes, it should be S2, S1, S0 bar, plus D7, we will have S2, S1 and S0. Okay, so based upon this truth table, we have this expression. So now this expression can be easily realized using logic gates. Okay, so I think all of you can go through or do this by yourself also, but okay, let me do it. So for that, as we have three combinations for S2, S1, S2, S1 and S0, so we will have three inputs, the inputs or the lines for S3, S1 and S0. So as we have the complement of all these terms also, so let me take the scale so that I can draw. Okay. Oh, और चलो छोड़ो इसे, छोड़ता हूँ फिर से। लास्ट टाइम मैंने इसे देखा था बट अभी फिर से नहीं हो पा रहा है ये। ओके, चलो इसे छोड़ता हूँ। So we have three possible combinations for S3, S1 and S0. So I am taking the three lines for these inputs, 1, 2 and 3. So also we will have the complements. We need the complements of all these inputs. So let me change the color. So the blue lines are the complemented part. Okay, so except this, we will have the enable input also. So let us take another input for enable input. And the complement part. Okay, so here we will have, so for the first for the first expression part, first part of the expression, what we have D0, D2, S1 and S0. So we can take the different inputs also. We have to take the different inputs also as D0, from D0 to D7. Okay, so we need some more lines for like D0, for D1, for D2, for D3, D4, like this. Okay, so firstly we have this input D0. So okay, let me change the color. Okay, so first input as D0, second as S2 bar. So where we have S2 bar, here S2 should be here, S2, S1, S0. So S2, S1 and S0. So let us take S2 bar, S1 bar and S0 bar. Okay, so except this, what we need also the enable input. So enable का complement चाहिए हमें. So enable complement है, इसका 0 चाहिए. So 0 कहाँ से मिलेगा हमें? 0 मिलेगा यहाँ से. Okay, so one more input will be from this enable part. So yes, so here it is the AND of all these terms. In the same way, we will take the terms or the inputs. So for D1, we need S2 bar, S1 bar, and S0. So S2 bar, S1 bar, and S0. So S0 is here. Instead, we will have one more input, which is from this E2 bar. Sorry, E bar. Okay. So again, we will have this term. So in similar manner, we have to take all the inputs, and what we can see here that all of these terms are odd together. ये सारे terms आपस में odd हैं, तो इस तरीके से हमें total यहाँ पर 1 2 total 8 AND gates यहाँ पे मिलेंगे. Okay, so let me draw it for you. So आप लोग इस सर्किट को कंप्लीट करोगे. 4 5 6 7 और 1 8. So we will have these 8 AND gates, and we will have the outputs from all these AND gates, and the outputs of these AND gates will be odd together. Okay, so we will OR all these outputs. We will take the OR of all these outputs, क्योंकि जो expression है, according to that expression we need an OR gate. Okay, and all of these inputs are odd together. यहाँ पर जो आउटपुट आएगा वो that will be an output of y, और हमें अगर y bar भी लेना हो तो what we will do, we will take a NOT gate from this output, and we will have the output y bar also. So similarly, जो जिस तरीके से हमने दो AND gates को आपस में combine किया है, in the same way we can combine all these inputs together. So इन सारे lines को हमें आगे बढ़ाना होगा और inputs देने होंगे. ठीक है, so ये देखने में ये काफी आसान लग रहा है, but for this initial stage you need to do these things. ओके, सो इस तरीके से इनपुट्स हैं हमारे पास. D3 है, फिर हमारे पास यहाँ इनपुट आएगा लाइक D4, D5, D6, D7. ओके, सो D0 1 2 3 4 5 6 7. Okay, so I have drawn here 7 AND gates also, 8 AND gates also. So in the same way we will connect all these inputs based upon the expression. तो जो ये expression हमारे पास है, आप लोग देख पा रहे हो, ये जो एक्सप्रेशन हमारे पास है, ये एक्सप्रेशन से हमें ये लॉजिक डायग्राम मिला है. ठीक है, सो इन द सेम वे वी कैन डिजाइन अ 16:1 मल्टीप्लेक्सर आल्सो. सो 16:1 मल्टीप्लेक्सर में क्या होगा, अगेन अगर हम अब 16:1 मल्टीप्लेक्सर की बात करें तो okay, so system has gone somewhat slow. Page is not moving. ओके, सो अभी अगर हमें बनाना हो क्या, 16:1 मल्टीप्लेक्सर बनाना हो, 16:1 मक्स अगर हमें डिजाइन करना है, तो इन द सेम वे वी कैन डिजाइन 16:1 मक्स. और इसका जो आईसी है, इसका भी एक आईसी है, IC 74150. सो दिस इज द आईसी फॉर 16:1 मक्स. सो दिस 16:1 मक्स कैन आल्सो बी डिजाइंड यूजिंग 2 8:1 मक्स. ओके, तो 16:1 मक्स का ये आईसी तो है हमारे पास. सो जैसा कि हमने 8:1 मक्स को डिजाइन किया है, इन द सेम वे वी कैन डिजाइन 16:1 मक्स आल्सो. सो उसमें क्या होगा, 16 AND गेट्स हमारे पास होंगे और एक OR गेट होगा इन दैट केस. ओके, और नेक्स्ट वी कैन डिजाइन दिस 16:1 मल्टीप्लेक्सर. ओके, सो ये जो हमारे पास 8:1 मक्स हमने यहाँ पर देखा है, based upon this 8:1 mux, we can draw this truth table for 16:1 mux also, and in the same way we can draw this logic diagram for 16:1 mux. Okay. Now these higher order multiplexers can also be designed by using smaller multiplexers also. So we can design 16:1 mux using 8:1 mux और 4:1 mux, है ना। तो इस तरीके से हम लोअर वर्जन का मल्टीप्लेक्सर का इस्तेमाल करके वी कैन डिजाइन हायर वर्जन ऑफ द मल्टीप्लेक्सर्स। ओके, सो अगर हमें अब अभी 8:1 मक्स अगर इस्तेमाल करना है, सो इम्प्लीमेंट 16:1 mux using 8:1 mux. Okay, हमें ये करना है. This is our motto. So how we can do that? So in this case we require 2 8:1 mux because हम लोग क्या जानते हैं कि जो 8:1 mux होगा, 8:1 mux में जो सेलेक्ट लाइंस होंगे वो नंबर ऑफ सेलेक्ट लाइंस कितने होंगे? 8:1 mux में सेलेक्ट लाइंस कितने होंगे? 3 होंगे. ठीक है, तो क्योंकि अब हमें 16:1 मल्टीप्लेक्सर बनाना है, तो 16:1 मल्टीप्लेक्सर में नंबर ऑफ सेलेक्ट लाइंस कितने होंगे? 4 होंगे. तो अब वो जो फोर्थ वाला जो सेलेक्ट लाइन होगा वो एज एन स्ट्रोब इनपुट और एनेबल इनपुट वर्क करेगा. कैसे देखते हैं हम. मैं एक छोटा सा ब्लॉक डायग्राम बना रहा हूँ, आप लोग आई थिंक उससे समझ पाओगे. सो वी विल हैव 2 8:1 mux. Okay, we have 2 8:1 mux, and these 8 is okay. So this is 8:1 and this is also 8:1. We can assume it as IC number क्या था वो? 74151. It is also IC 74151. So in this case हमारे पास जो ये 8:1 mux है, यहाँ पर जो 8 इनपुट होंगे D0 से लेकर D7 तक, 1 2 3 4 5 6 7 8, स्टार्टिंग फ्रॉम D0 टू D7, ये सारे पिंस तो हो गए. इनके अलावा सेलेक्ट लाइंस चाहिए होंगे. ठीक है, तो जो सेलेक्ट लाइंस, क्योंकि ये 8:1 mux है, तो अगर 8:1 mux है तो वी विल हैव 3 select lines, and those 3 select lines will be common for all both of these ICs, like S0, S1 and S2. Again here also S0, S1 and S2, and the fourth select line will act as the strobe input. So strobe input means what? It will work as an enable input. So the fourth one जो है select line, तो उसे हम ऐसा लिख सकते हैं like S3 can be given as an strobe input as this. So this is enable and this is enable input. Okay, so आप समझ पा रहे होंगे कि here we have to design 16:1 multiplexer using 8:1 multiplexer. So in this case we already know that in 8:1 multiplexer we need 3 select lines, and for 16:1 multiplexer we need 4 select lines. So the 4th select line will be used as the strobe input or the enable input. So for the particular case from 0 to 7, chip 1 will be activated, and from 1 2 3 4 5 6 7 8, मतलब from D8 to D15. Okay, अब ये जो इनपुट्स है D8 to D15 जो होगा, ये आइदर ये चिप सिलेक्ट होगा और ये चिप सिलेक्ट होगा बेस्ड अपॉन दी आउटपुट रिक्वायर्ड। अभी अगर हमें मान लें कि D0 1 2 3 हमें D4 चाहिए आउटपुट में, तो ये चिप एक्टिवेट होना चाहिए, चिप 1। और अगर हमें आउटपुट में 8 9 हो गया, ये 10 हो गया, ये D11 हो गया, हमें अगर D11 आउटपुट में चाहिए होगा, देन pin 2 should be activated. Okay, so based upon the select lines we will have the inputs, we will have the outputs. So अब ये जो आउटपुट आएगा, मान लें अगर D4 हमें आउटपुट में चाहिए, तो यहाँ D4 मिलना चाहिए और यहाँ 0 मिलना चाहिए, लेकिन दोनों का आउटपुट जो कंबाइन करके वो हमें D4 मिलना चाहिए। तो इसके लिए हमें क्या करना होगा, इसके लिए हमें क्या करना होगा, we need an OR gate, so that after this combination, here we have D0, here we have a D4, here we have a 0. So at the output Y, we need D4. So it will be at the output only when we will use an OR gate. Or in this way, we can see that 16:1 multiplexer can be implemented or designed using 2 8:1 multiplexer. Okay. Is it okay? Is it okay?
Yes, sir.
Okay, let me give you some more things so that you will get acquainted with the multiplexer. Okay, I'm giving you very basic data, and based upon the data, you have to give me the answer. So yes, please see the board. Here, it is a question. Okay. Question is what? That cursor is stuck. It is not moving. Okay, now. So here I am drawing a block. You have to tell me the output. Okay. So here it is a 4:1 marks. And here we have 1, 2, 3, 4 inputs are here as I0, I1, I2, and I3. And here an input C is given and it is shorted with this input. And here also we have an input of C bar and it is shorted with this input. Okay, so please tell me the output. So here there are two select lines as S0 and S1. So what is the output here? So please do it on your copy, or if you can do it mentally, then please tell me the answer. So can anybody tell me the answer? Has anybody done it? So how you will proceed? How you will proceed? So from the this block diagram, you have to go through the expression. Okay. So how you can write the expression? How you can write the expression? How you can write the expression? As we have already seen, 2:1 marks. Sorry, 4:1 marks, 2:1 marks, 8:1 marks, 16:1 marks. So now we have you have to write down the expression. So what is the expression? Or you can also draw the truth table. So based upon the values of S0 and S1, what are the output? So the combinations will be 0, 0, 0, 1, 1, 0, and 1, 1 for S0 and S1. Now we need the output. So what is the output here? The output will be I0 for this first combination. For the second combination, output will be I1. For the third combination, output will be I2. And for the fourth combination, output will be I3. So what you can see here, that what is the value of I0 and I1? As you can see that I0 is connected with C and I1 is also connected with C. So this is equal to C and this is also equal to C. And what is the value of I2 here? What is the value of I2 here? What is the value of I2?
C bar.
It is C bar from the question, according to question, and value of I3 is also C bar. So now if you write the expression for this multiplexer, so Y output, so we have already seen the expression as I0 S2 bar, sorry, S1 bar, S0 bar plus I1 S2, sorry, S1, S1 bar S0 plus I2 S1 bar S1 S0 bar plus I3 S1 S0. ये expression हमने already देख लिया है. Okay, so we can put the values of S0 as the values, all the values here. So based upon this value, what you can observe, based upon this value, what you can observe, the values as for this particular case, जब S0 और S1 का वैल्यू 0, 0 है, तो वैल्यू हमें क्या मिल रहा है? यहाँ पर C मिल रहा है. So here it is C. For the second case, again we have C. For the third case, we have C bar. And for the fourth case, we also have C bar. So what should be the output? What should be the output?
One.
It should be C plus